And now for the third of our three different perspectives we take in physical geography. We covered the environmental perspective and the science perspective. We just looked at feedback loops and systems thinking and scientific method in defining science. And what we want to think about now is what really is unique to geography is thinking spatially across space. And we have three random examples here. Looking down at Earth from a satellite across space, you can look for certain things like water or cloud distribution. On the right, we see the average annual distribution of rainfall across India and surrounding countries. And in the bottom, all these scribbly lines of different colors represent hurricane tracks over a long period of time. So again, thinking spatially. Why are hurricanes occurring more so over here than, let's say, up here in the Pacific Northwest, where there isn't any at all? Why is rainfall more concentrated on the west coast of India instead of the southeast coast? What's going on? Why are clouds forming here but not over here, and so forth? Thinking spatially, looking for patterns, understanding distributions. That's a big part of what we do as geography, as geographers. And what's cool about it is that you can take any topic you want to. It doesn't have to be weather related. It could be human related, thinking about people moving over space, or maybe cafe positions across town. Why are they located where they are? Why is what where, is what we like to say concerning the spatial perspective. Why is what where? And there's a lot of information that you can get from studying things spatially. Just this one image here, a nighttime image of North America. You can see city lights. And naturally, our eyes are very, very good. Our brain's very good at pattern recognition. And when we see this, we can instantly start to form patterns and see things emerge. For instance, take a second here, come up with some of your own ideas before I tell you mine. What do you see here? What kind of patterns? What kind of distribution? What does this tell us? What does night lights and city lights, what does that tell us? Right? It tells us where human civilization is across North America. Right? When we see clusters of lights, those are our cities. There's some cities in Texas. Here's Chicago up here. Here's this big megapolis stretching up from Boston down through New York City and Philadelphia into the Baltimore, Washington, D.C. area, and so forth. We can see that population is more densely populated here on the East Coast versus the West Coast. And when we look at Canada, see most of Canada is in the southern reaches of their vast territory. Not a lot of folks living up here in this cold, very difficult to live in type of climate. And we can see this is not random. This is definitely has a reason why people were down here. And when you investigate, you start to realize, oh, it's extremely cold and difficult to farm and to get by in these areas up here. Speaking of Canada, is a random geography question. Who has a greater population, California or Canada? Survey says. Well, we have 38 million people living in Canada, according to the 2014 census estimates. And in Canada, only 35 million. So we actually have more people living in Canada than the entire country, or more people in California than the entire country of Canada, which I think is pretty wild. Thinking spatially with weather and meteorology, we look at distributions of storms. One of the signatures of storms that bring us all kinds of crazy weather looks like this. This would be a low pressure system, and watching it as it crosses our country. Is it going to go more west to east? Is it going to take this north and southward meander that often occurs? And who's going to get rain? Who's going to be dry? That's thinking spatially. And then the mechanisms, not just being happy with that fact, but what's the mechanisms of why? Why is the storm here? Why is it more common to find storms and rain in the southeast of the U.S. than the southwest of the U.S.? What keeps these systems from frequently moving across northern Mexico and the southwest, the arid regions of our continent? Why are volcanoes in the hundreds of tens to hundreds of thousands around this ring of fire Not a random pattern. Why do we have this ring of volcanoes? And very, very little. Here's one example, one exception, Hawaii, out in the middle, but very, very little volcano here in most of the Pacific Ocean. Well, that's because of the plate tectonics. And so volcanoes tend to form along plate boundaries, and that's where the plate boundaries are, and all these red dots are the volcanoes emerging. Hawaii, by the way, is the exception. It sits out under a hot spot, which is not related to tectonic boundaries, but below the plates there is an exceptionally hot area and down deep in the earth, below the crust in the mantle, that allows magma to breach through and break through this crust, this plate. Thinking about tornadoes. When I lived in Texas and moved to Alabama, looking at this map, I thought I was safe from tornadoes. Boy, was I wrong, right? But thinking spatially about severe storms, and meteorologists, climatologists are definitely rethinking the idea of this tornado alley, getting rid of it, maybe calling it Tornado Valley and extending it over into the Appalachians and including Mississippi and Alabama, Florida, who actually gets a ton of tornadoes as well, and not leaving it to this very narrow strip of Tornado Alley. And lastly here, thinking spatially with a kind of a fun example, this is showing dots of a ratio, if we look at the legend, of grocery stores to bars. So if you see a dot that's very, very brown, that means they have more than 3 times more bars than grocery stores. And the very, very green, 3 times more grocery stores than bars, which I think is pretty hilarious. And this was posted by an old professor of mine who happens to be from Wisconsin and was curious why Wisconsin has way more bars than grocery stores. But kind of a neat spatial distribution that emerges here. The Bible Belt, not surprisingly, has far fewer bars. And I'd imagine this would look even more intense if you did a churches to bars ratio. In fact, I would love for someone to do that. That would be really cool. And you'd really see the Bible Belt shine then, I'm sure. So again, thinking spatially, looking for patterns, and then trying to find meanings and explanations behind the underlying processes of those patterns. That wraps up our Introduction to Geography video series. I hope you have enjoyed it, and if you have questions, email me anytime or swing by my office. All right, thank you.